Alright, so now we're going to talk about the mean value theorem. This is a generalization of Rolle's theorem. I'll show you how it's a generalization of Rolle's theorem in a bit. But if you read along with me, it says, let f be a continuous function that satisfies the following hypotheses. The first one, f is continuous on the closed interval a to b. If you look at Rolle's theorem, those two first hypotheses are exactly the same. Now, if you read number 2, f is differentiable on the open interval a to b. That one is also the same as Rolle's theorem, okay? However, there's no third condition. But now it says, then there's a number c in AB such that f prime of c is equal to, so f prime of c is equal to f of b minus f of a divided by b minus a. Okay, so now let me point out to you how this is a generalization of Rolle's theorem. So in Rolle's theorem, f of a is equal to f of b. So they're the same thing. So this numerator up here, if f of a and f of b are the same thing, f of b minus f of a must be equal to 0. So 0 divided by b minus a are different numbers here. So you get 0 divided by a number, it's going to equal 0. Okay, then you get right back to Rolle's theorem. So that's just applying the third condition. Let me draw you a picture. Here's A, and this would be f of A. Over here is B, so I'm at some f of B. And you've got some function between a and b. Now, this is a continuous function from a to b. It's definitely differentiable. There's no discontinuities or there's no sharp edges. It's nice, smooth. So, what this is saying is that if you have a continuous function that's differentiable, then there exists some number in a and b, some number c. I'm not going to put it on here yet. There's some number c in this interval such that the derivative evaluated at that point c is equal to, now think about what that looks like for a second, and think about what the derivative means. The derivative means slope. So a slope must be equal to, this is another slope. That's the slope of the secant line between A and B. So if I were to draw the secant line from A to B, like that, I missed a little bit, that's okay. That says that I can find some number C where the derivative has the same value. So I'm just going to line it up and go up until it looks like it's tangent somewhere. And it looks like I'm tangent right there. I'm tangent about there. Okay. So there could be other numbers here, like down here. It depends on how much I curled it. But it looks like I could stick another one right there. It's a little off. Let's see. So there could be more than one number C. So right there would be C. And right here, the slope of this line would be m is equal to f prime of C. So that's what the mean value theorem is guaranteeing for us, that if we have a continuous function that's differentiable on some interval, then we for sure can find somewhere where the derivative is equal to the slope of the secant line. So now let's go ahead and go through the proof. m is equal to, so this was the slope that we had. And here's our points that we had. At A, we were at f of A. At B, we were at f of B. Okay, so if we use point slope form, y minus y naught is equal to m times x minus x naught. We're going to use this point right here. So we got y minus y naught. Y naught is f of A. Is equal to the slope. Here's our slope. F of B minus f of A divided by B minus A times x minus x naught. X naught is just A. Now I'm going to add f of A to both sides. And now I have the equation for the secant line. There we go. It's right here. Alright, so I gotta do some erasing. So all we did right now was write the equation for the secant line. Now, let me draw you another picture to explain what we're doing. We're going to create a new function here. Right there's A, right there's B, something like that. Let's see, I'll draw the secant line in a different color. This is y right here. This red line is f of x. And what we're going to do is we're going to create a new function and call it h of x and make that equal to f of x minus y. So all it is the difference between the y coordinates. So if I've got a y coordinate right there, and then I've got the same y coordinate right there, you just subtract the two, and that right there would be h of x. Okay, so now we got a new function. H of x is equal to f of x minus y. So I'm going to erase everything and write what this equation looks like, but I'm going to plug in my y. So h of x is equal to f of x minus, now remember we're plugging in that equation that we had for y, f of a minus, see, f of b minus f of a divided by b minus a times x minus a. So we've got a new function. Now, let's go ahead and use Rolle's theorem. When we initially started this, we assumed that f was continuous and differentiable on the interval from a to b. So, that satisfies the first two conditions of Rolle's theorem. Now, let's find h of a. Well, that's equal to f of a minus f of a minus f of b minus f of a divided by b minus a times a minus a. A, or f of a minus f of a, that cancels right there. So that's 0. This right here is just a number. Remember, it's just a slope. But a minus a. This right here is also 0. 0 times a number is 0. You got 0 minus 0. H of a is equal to 0. Let's go ahead and find f of b. Or h of b, sorry. H of b is equal to f of b minus f of a minus f of b minus f of a divided by b minus a times b minus a. This b minus a cancels with this b minus a. So now you've got f of b minus f of b, which is 0. You've got f of a minus a minus, so that's a plus. So negative f of a plus f of a, that's a 0. So you've got h of b equaling 0 as well. So f of x is a continuous differentiable function. This is just a line. So h of x satisfies the first two conditions of Rolle's theorem. Not only that, we showed h of a is 0, h of b is equal to 0. So h of a is equal to h of b. So this new function that I have satisfies all three conditions of Rolle's theorem. So that means, I'm going to keep that up there. Since all three conditions of Rolle's theorem are satisfied, there's some number c in a and b such that h prime of c is equal to 0. So all that means is take the derivative of this thing, plug in c, and set it equal to 0. So the derivative of this function, so h prime of x is equal to, well, derivative of f of x is f prime of x minus f of a. F of a is just the number, so that's 0. Over here, if you notice, this right here, that's just a number. It's just a slope. F of b is a number, f of a is a number, b minus a is a number. It's just a number. This right here, x, this is the number. The derivative of a number, gone. X, the derivative of x is 1. We got 1 times this thing. We're going to have f of b minus f of a divided by b minus a. And now we plug in c, set it equal to 0. F prime of c is minus f of b minus f of a divided by b minus a equals 0. And now all we have to do is add that to the other side, and we get our final result, which is the result of the mean value theorem. So plus f of b minus f of a divided by b minus a f prime of c is equal to f of b minus f of a divided by b minus a.